Section 2.3b is about multiplying rational numbers, so we're going to continue that process. I'm going to put the rules for multiplication up here so we can have them in front of us. So here we go. Positive times a positive is positive, negative times a negative is positive, and then positive, negative, or negative, positive is negative. In other words, if they're the same sign, it becomes a positive product, and if they're different signs, it's a negative product. So down here, we know the answer will be negative because they're different signs. We just have to multiply straight across. 5 times 2 is 10, and 3 times 7 is 21. Nothing cancels. We knew it was negative, so there we go. Next one, same idea. We know it will be a negative product because the signs are different. 4 times 7 is 28, and then 9 times 5. Well, 9 times 10 is 90. And 9 times 5 is 45, and 90 and 45 is 135. Here we're going to evaluate. We're going to take the n of negative 2/5, put that in place of my n. When you do that, you're going to square that because n is squared, and then you're going to multiply it by negative 5/8. PEMDAS says to do exponents first. So we'll square negative 2/5. When you square something, you multiply by itself, and a negative times a negative is positive. So this is really a 4/10 that's positive times a negative 5/8. Now I could just multiply these across and do fine with that, but I also want to remind you that there's such a thing as cross canceling. You see 4 goes into 4 and 8. 4 goes into 4 once and into 8 twice, so we can cross cancel there. I can also cross cancel the 5s. 5 goes into 5 once and into 10 twice. So that may make this fraction a little bit easier. 1 times 1 is 1. 2 times 2 is 4. And because the signs are different, this is a negative, we get a negative 1/4 for my product. Here we're going to continue to evaluate, and hopefully by watching me do a couple, you'll learn the process. 6 times m, so I'm going to multiply. Instead of an m, I'm going to use negative 2/3. Now the way I like to do this is make 6/6/1, because then you're able to see the cross canceling a little bit better. 3 goes into 3 once and into 6 twice. So 2 times 2 is 4, and 1 times 1 is 1. Because the signs were different, we end up with negative 4/1. I suppose I should not write that as negative 4/1, but as negative 4, because that's what anything over 1 is, just itself. Next one, n times p. n is 1/2. p is negative 3 and 3/4. I'd prefer that to be an improper fraction. So I'm going to multiply 3 times 4 and get 12. Then I'm going to add 3 and get 15. And I'm going to put that over 4. So this is really a negative 15/4. No cross canceling that happens here. Positive and negative means the answer will be negative. 1 times 15 is 15. 2 times 4 is 8. So negative 15/8. And the last one, n squared, which means we'll plug a 1/2 in for n and square that. And then multiply it times m, which is negative 2/3, plus 2. Now I'm going to make this a 2/1, and you'll see why in a little bit. When you square 1/2, you square the 1 and get 1, square the 2 and get 4. In here I need common denominators. So it looks like a common denominator will be a 3. And the reason I made this a 2/1 is because I knew I was going to multiply by 3/3. So rewriting this, negative 2/3 plus 6/3. Here's an example in the parentheses of adding. So we have to go back to the section about adding and go through that rule again. Same signs, we're going to subtract. So negative 2 plus 6 is really, and I'll do this in orange, it's really 6 minus 2, because different signs means take the bigger minus the smaller. That's the DSS idea. And 6 minus 2 is 4, and because the 6 is bigger, it's going to be a positive 4. So 1/4, and that'll be a positive 4/3. There's cross canceling again. 4 goes into 4 one time. Positive times a positive is a positive 1/3.